You guys have doubtless seen a probably better crafted image than the one on the board there.
Honestly, I was proud of that.
Thank you. Yeah, it's supposed to show the progress of human evolution, and that's going to be our topic for tonight. I need to make a correction to something I said in a previous video, though, or previous class session. I'm making most of it because I'm on the internet, so I got to get my corrections in. I have a very distinct memory of seeing side-by-side comparisons of different species of ape next to different races of human. And I attributed those pictures to Charles Darwin's book, The Descent of Man. Charles Darwin does describe these similarities in The Descent of Man, and he does propose that the different races of humans are descended from different species of ape. And I believe I also said that he of course proposed that the white Europeans were descended from intelligent chimpanzees, whereas the black Africans were descended from dumb, brutish gorillas. And those claims are all true. However, they're not true. What's true is that Darwin wrote that. What is not true is the pictures. I have a copy of The Descent of Man on my bookshelf, and I could have sworn that he had hand-drawn pictures outlining the similarities between the head shapes of the different races and the apes they supposedly evolved from. But I could not find those pictures in The Descent of Man, so I have to retract that claim. To my knowledge, Charles Darwin, or to my ability to locate them, I have not been able to find pictures drawn by Charles Darwin comparing Africans to gorillas and Europeans to chimps and so on. So I don't know where I saw those pictures or if I just invented them in my head, but the idea is present in Charles Darwin's The Descent of Man, but the pictures are not. So that is my roundabout way of apologizing for claiming that they were. That said, we are on page 63 in your workbook here. And last time I gave a big heap of science, so this time I'm going to try to kind of chill out a little bit. We're still going to go into the science, but maybe we won't go quite as hard as we did last week. But I do want to start here with Charles Darwin, with the descent of man in general. So last week we talked a lot about beginnings. We talked about the Big Bang Theory as an idea for how the universe began without God. And then we talked about a couple of different theories of how life began. So putting aside the question of where the planet came from, there is a separate question of where living things came from. Because what we observe scientifically is that living things only come from other living things. And so there's a big question that evolutionists need to answer is where did the earliest living things come from? And the answer is either completely speculative, like lightning struck a primordial soup just right and suddenly there was life. We've never been able to imitate that in a laboratory, even when we really, really try. And then the other explanation just kind of kicks the can down the road and says we don't know where life came from. Perhaps it originated somewhere else in the universe and somehow traveled through the vast vacuum of space without, dying and found its way to Earth that way. That theory is called directed panspermia, and is listed there on the second bullet point on page 63 in your book. There's a big space there that I want to dedicate to talking about human evolution in particular. Because according to the Bible, we humans have a very special place in creation. The evolutionary tree of life, where different species, branch apart from different evolutions and go extinct and this, that, and the other thing. The evolutionary tree of life would suggest that humans are just one branch on the tree. So I don't know, let's say we're here. And we've got the birds over here, and the fishies over here, and the lizards over here. That's a snake. There, the snake's over here. I was like, I don't know how I'm going to draw a lizard real quick, but there it is. That's a snake. So humans are really just another kind of animal. We are a particularly intelligent brand of mammal. Vertebrates, you can go down to all the different. It's called taxonomy. This is called the taxonomic hierarchy. And anyway, that's what evolution would say. The Bible says that actually, we don't know what exactly the tree of life looks like. It's probably cut off somewhere around here. This would be the creative act of God, and then things kind of diverged from there. But the Bible puts mankind on a totally different tree than the tree of life. We are not just another animal. We are something absolutely different, not just another branch on the family tree. Were any of you guys at Vacation Bible School 2 summers ago when I was an Australian guy? Yeah? So there was a song that just lists a whole bunch of animals, and it's a really fun song. And then in between the verses, there's just a couple guys talking, and one of them says, in an Australian accent, he says, "We're not just another branch on the family tree. We're on a whole different tree." And the other guy's like, "Trees? I thought we would talk about animals. Animal trees?" Yeah. So anyway, if you still have the CD from that, the song's worth a listen. And this is the idea being put forth, is that humanity was created special by God. And the claim that we are just another branch on the family tree is particularly offensive to Christian doctrine. So I thought it would be worth our time to take a particularly close look at that claim. So I talked about the inherently racist aspect of evolutionary theory. Here's something fun for you. You don't have any homework for tonight. I chose a particularly long article about the interplay of evolutionary thoughts and racism, and I was not able to generate a proper assignment for you to hand out by tonight. Here's what I'm going to do, though. I'm going to publish it online with the video, and I'm going to hand out a hard copy in class next week, and the week after next is when that assignment will be due. It's a very interesting article about how the theory of evolution kind of, racism has always existed because people are terrible, and that's just a fact. It's a fact because of sin. And but Charles Darwin, especially his book, The Descent of Man, really kind of rocketed, it gave racism a scientific legitimacy that it did not deserve. Thankfully, modern science has kind of debunked all of that, but a lot of racism in modern history can be traced back to Charles Darwin's ideas on the descent of man, and the fact that, not only is man a branch on the family tree, but the different races are different branches on the family tree, and they are not all equal. So that was what Darwin wrote in The Descent of Man. So you've likely seen this before, this picture, where we've got, something like a chimpanzee over here. Technically, it is an ape-like ancestor of mankind, and there are fossils of this creature, because it's like a totally different species, and there are fossils of this creature, because, it's a human, and there's a few billion of them lying around that we could dig up and call fossils. But there do not exist fossils of these two or anything else in between the man and the chimp. There's a very small set of what so-called transitional fossils, and I'm going to write that down here. So we're going to call these transitional. And they are hotly contested, and really you don't have to be a biologist to look at them and realize, that one is actually just a human with an odd-shaped skull. Oh, that one is actually just an ape. And there are plenty of scientists who are willing to admit that we really don't have any fossil evidence of these transitional forms. And so this reality, perhaps you've heard this term before, is called the missing link. So evolution predicts that there will be fossils of all of these forms. We should be able to find in the fossil record these transitional forms, because evolution, after all, takes millions of years. So, we've got this guy existed for 10 million years, and this guy existed for 10 million years, and this guy existed for 10 million years, and this guy existed for, 5 million years or whatever. I don't recall the exact times for each one, and of course, every textbook is going to have a slightly different scale anyway. But with millions of years of the existence of one of these species on the Earth, we should be able to find some fossil evidence that they actually existed. And we don't. That's why they're called the missing link. Have any of you heard the phrase missing link before? I'm just curious if it actually makes it into the parlance of scientific discussion these days. It's called a missing link because it's missing. And the theory of evolution predicts that it would not be missing. So the fact that it is missing is troublesome, to say the least, for those who embrace evolution. And of course, the same missing link exists for like every other species. The transitional forms from the ancient ancestor of two different modern species. There are no transitional forms. You have fossils of the modern species, and you have fossils of the so-called ancient ancestor that went extinct. Now, of course, we live in a world of sin and death, and it's a sad reality that creatures go extinct. Things are lost and destroyed. That is not contrary to Christian doctrine at all. So there are extinct species in the fossil record that look kind of like modern species, but different enough that scientists agree there had to be something between what we see and what we got. And we don't have anything. There's nothing there. The missing link. So some evolutionists have said, okay, well, maybe there was a dramatic change in the environment, and we actually transitioned from this all the way to this in a relatively short time. But there's not much evidence of that dramatic change, except for the evidence of Noah's flood, which is a one-time event, and they deny the flood anyway. So they do all kinds of weird stuff with that. But the other thing that I found interesting when I read The Descent of Man for the first time, I have to admit, I only kind of skimmed the highlights of Origin of Species. It's a very dense text, and a lot of it is dated anyway, and Darwin, I've only got 24 hours in a day, so I haven't read Origin of Species that closely. I have read The Descent of Man, which is the more controversial. I think I mentioned last time that The Origin of Species was kind of Darwin playing it safe and sticking to the facts and only speculating a little bit on the actual origins of all life and everything. But when that really got traction, then he was a little more bold and produced the more controversial Descent of Man. And what got me in Darwin's writings is that he bases so much of this idea that there's a smooth transition from one to the other. He bases it on the idea that they look the same. I mean, that's like literally it, we have people who walk on two legs and have 5 fingers and opposable thumbs and whatever, 4 fingers and opposable thumbs, and we have apes that kind of walk around on 2 legs and have 4 fingers and opposable thumbs. And so his idea is basically they look similar, therefore one must be descended from the other. And I'm going to write that down, Darwin's assumption. Let's see, I'm gonna break it down into a very simple drawing. It took me way too long to draw that. So I want to use simple shapes. So if you see a green square and you see a blue square, the assumption is that both of these squares come from a single square ancestor. And of course, I don't have a blue-green marker. I do, but it's in the basement. So, I don't know, we'll call it something like this. Darwin's assumption is that this is what we see. So if you've never seen this before, this is the scientific sign for observation. It's like a literal primitive eyeball-looking drawing. This is what we see, and this is what we assume. Got too many arrows now. That's a huge assumption, is kind of what I'm getting at, is we see two things that look similar, and we assume that they come from a common ancestor. And there's really no reason to make that assumption. I have a fun analogy that I read that I'd like to share. Suppose for a minute that you were put in charge of building a bridge. You work for the city, you're some kind of higher up, and you've got a river there, and you want to build a bridge over that river. And so you put out your request for proposals like you're supposed to do, and you get two architects, or engineers, they'd be engineers, two different engineers come to you with ideas. And one of them says, let's see here, I'm just gonna build a basic bridge here with structural supports and stuff. One of them says, sorry, I took an engineering class, I should do better than that. I took an engineering major, that's my degree. In any case, one of the engineers who wants to build this bridge says every bridge I build is totally different than the last. It's a work of art, man. And just because I built 6 other bridges, they all look different, I'm not going to do any of that stuff. You're going to get a whole new product. And the other guy says, I actually follow the same basic principles and design with just about all of my bridges. And I just kind of customize it. I change up a few variables to make it fit the context of the river that it's going over. Which engineer should I hire? Should you hire?
Oh, number 2.
Second.
The second one, yeah. So, all right, how do I make this connection? So this is a principle of design, right? If you find a design that works, you use it and you stick with it. So in practice, in biology, we see a lot of similar structures in creatures, right? So we have humans and apes, both have 5 fingers and walk around and have a similar structure, yeah. Does that mean that that humans and apes both have a common ancestor? Or does it mean that humans and apes have a common designer? So how would I, let's see, Christian assumption. This is still an assumption because, like Stacy Lung told us a few weeks ago, we can't know, we can't prove the past. But we see the same thing. And, I don't know, we'll give Christians green eyes here because I'm holding a green marker. We see the same thing, but we believe that they both were conceived by the same mind. So how do I write that? I don't know. We'll call God like a big bright ball of light here. And the lines that I want to draw are going to come down like this. There we go. So the Christian assumption, the observation is the same, and I do want to make this point, okay? This is a classic case of Christians and creationists and evolutionists are not finding different pieces of evidence that support their theory. They are finding the same evidence, and the fight is not over which evidence is better. The fight is over how to interpret it. So the evidence that we see is we have very similar but different species of animals. And the assumption from Darwin is that they must have descended from a common ancestor, whereas the assumption for creationists is that they are made by a common designer. Because when God designs a structure, a biological structure that works, He's not going to use it one time and then chuck it. He's going to use it in as many different kinds of animals as He can, or as He chooses to. I'm sure God did not stop at the limits of His infinite power. But the main point that I want to make here is that common features imply a designer. I should have written single designer, or one designer. So whereas Darwin simply looked at similarities between, say, different, the finch example is actually pretty solid, so I don't mean to attack that one, but do you know Darwin's finches? So yeah, in case you don't, I don't want to go down that. Darwin did a good thing with finches, and then he took that to just like a logical extreme that isn't valid. Because what he saw was different birds on different islands that were all finches, but they all had different adaptations that were better suited to their different islands. And so he assumed, probably correctly, that they all descended from a single pair or single population of finches that at one point in the past had all of those qualities within their own genes. But then he went on to be like, hey, you know, turtles and snakes are both cold-blooded and you know, have scales and stuff. So I bet they have a common ancestor too. And yeah, and you know, humans and apes and I don't know, horses and giraffes and whatever else, you know, he kind of looked at the whole animal world. It opened up his mind to places where maybe it shouldn't have been open. And he looked at the whole world, and any two things in the biological world that were similar looking or similarly structured, he saw that as evidence of a common ancestor. But the fact is that is that's an assumption, a rather big assumption. And with all of the missing links all over the so-called tree of life, it is an assumption that has not held water over the years. Now we are lacking a lot of fossil evidence there. There's another thing. This is just one example. Sometimes I like to teach you overarching principles, and other times I like to give specific examples. So I'm going to shift gears for a moment and give you an example. There's a fun phrase. You can write this down and look it up on YouTube later. It's called carcinization. Carcinization. This is an example. I'll write some EG over here. That's Latin for exemplar gratis. You see it a lot. It means for example. And it actually means like free example. I'll give you an example. Carcinization, you probably recognize the carcin in there as having to do with cancer. But actually it has to do, there's a zodiac constellation called Cancer. Does anybody know what animal it is? It's a crab. So carcinization has nothing to do with the cancer disease, but rather has to do with the tendency, let me see, I'm going to define it in evolutionist terms first. Natural tendency to evolve. I'm not making this up. I can't say it with a straight face. Natural tendency to evolve. All right, I won't say crabs. Crab-like features. So here's the deal. I erased my tree of life. That's a shame. All right, I hope you got your assumptions written down. So I need a lot of vertical space. So in the evolutionary tree of life, I'm just going to follow a few branches. Okay, so we've got your invertebrates over here and your vertebrates over there. So I guess these are animals. Kingdom Animalia, phylum Chordata. There's a song I learned about. So anyway, yeah. So I think all of the carcinization happens on the invertebrates, so we'll focus on that. But you know, you've got your, I don't know, your jellyfish and your worms and stuff like that, and then they branch off into other stuff as well, and some that they go extinct. But you know, in the end, you end up with something like this, where you have a whole bunch of animals that are only very distantly related, right? Like this guy over here and this guy over here. You know, they don't have any common ancestors for all the way back to here. And yet, for some reason, they're crabs. Even though they're not like, you know, you would expect, if this guy's a crab, you'd expect this guy to be maybe a slightly different crab, and maybe this guy's a lobster, and stuff like that. And you know, the farther away from this end of the tree of life you get, the less similar it should be. But what we end up seeing is that all over, not all over, there's like a dozen or so different species of, I think they're all invertebrates. They have all, independently of each other, supposedly, developed crab-like features. They have the same basic shape. They have, you know, the number of legs and I think claws and stuff. It's a really bizarre thing that evolutionists can't explain. Yeah?
Okay, so like, she's a Sagittarius and I'm a Capricorn. So they're telling me I look like a Capricorn?
No, this has nothing to do with your zodiac sign.
I'm not lost.
The word, I only use the zodiac sign to explain where carcinization comes from. Because if you know, like a carcinogen is something that gives you cancer. And so carcinization does have that root. But it's cancer as in like the crab that you see up in the stars if you connect the dots the right way. It has nothing to do with a disease. And so now, yeah, carcinization, look it up on Wikipedia. I kid you not. It's a really fun read. Carcinization, make sure you get the I in there. Carcination is something different. Carcinization is, this is like a technical definition. It is a natural tendency for populations to evolve crab-like features. The best the evolutionists can say is that nature really likes crabs, and they have no idea why. But crabs are appearing in places where the theory of evolution does not predict that they would appear. The theory of evolution says that, if this structure here, let me see, if this branch here develops crabs, so here's a crab. That's a terrible crab. I don't know. There. He's singing about living under the sea and all that. So if we get the crab development here, like, this is where the magic happens of evolution and the crab features develop, then any branches that come from there would, you would expect them to look like crabs because they all have that same structure. But for some reason, that structure did not only evolve here, it also evolved here, and it also evolved here. And this is just like, it's already unlikely enough that it would evolve even once. To imagine that this kind of structure would evolve multiple times on unrelated branches of the family tree are utterly ridiculous. It would be like, I don't know, I can't think of any good example. I was going to say like red hair or something, but red hair can pop up. It can be like genetically recessive, but this isn't just a hair color. This is like an entire structure of your body. This would be like, I don't know. Well, like, I can't even think of a good example. Like a person developing a third arm that actually works. So there are like mutants. We're going to talk about mutants in a little bit. There are mutants that have like a copy of a structure in their body, like a 6th finger or, a third arm or something. And the mutant structure almost always fails to function. It is bad. It is hurtful to the mutated thing. But in theory, if everything is right and the stars align, you might actually have a person born with like a second hand coming off of their elbow that like functions this? And stuff. Sure, I don't know. I'm making this up as I go. So theoretically it's possible, but it's never happened. Okay, and if it did happen, you'd be like, wow, that's amazing. That like, huh? That was scary. Yeah. Well, suppose that person has kids, and some of the kids have it too. You're gonna be like, okay, sure, that guy had the weird thing, and now his kids have the weird thing, and that's how mommies and daddies work, But suppose that weird thing happened, and then on the other side of the world, in a completely unrelated people group, you have somebody else has the exact same mutation, where they start growing a hand out of their elbow, and it actually functions. It's not just some weird freak thing. It's, it works. And you'd be like, holy cow, what are the odds of that happening? And then it happens 4 other times in completely different parts of the world. Yes, they're all humans, but they, you would have to think something else is happening here. It's not like, if it happens once, okay, maybe it was one of those 1 in a bajillion mutations. But for it to happen, 6 times, 12 times, whatever, you would think that there's no way. This is not happening by chance. You would, there'd be a conspiracy, there's some chemical in the water that's doing that, microplastics, global warming, they're going to come up with something, nuclear radiation, something is causing this mutation to suddenly happen. You would not just say, I guess nature prefers hands on elbows, because that is ridiculous, right? The best explanation for carcinization that evolutionists have come up with was, I guess nature just likes crabs. That's it. That's literally it. Nature really likes crabs, I guess, because they're appearing all over the tree of life, and that's bizarre. A more scientifically accurate assumption would be, darn it, I erased it, would be the creationist assumption, which is that all of these crab-like creatures are designed by a designer. You might say God really likes crabs because he used the same design in a whole bunch of different species. I think termites. Is it termites? There's some bug that isn't really a bug. It's like an arachnid or something, but there's some bug that has crab-like features in addition to actual crabs and there's marine, creatures and land-dwelling creatures and lots of different environments, lots of different scales. Some are big crabs, like, crabs. Some are very tiny crabs and crabs all the way down. It's really weird. So anyway, that's a fun read. And that is just one example of, many examples I could give. One example of God's creation doing something really weird and unpredictable by the evolutionary model. Because, all right, I'm going to get back into theory for a moment here. I said theory, that's funny. What is the purpose of a theory? Why do we develop scientific theories?
To answer our questions.
To answer our questions. To put it another way, to make predictions, right? So you look at the way things are, you develop a theory on why that might be, and then you use that theory to try to predict the way things are going to be. And if things end up going that way, then your theory has evidence in its favor. And if things don't go that way, then you say, oh, I guess my theory's wrong. Okay? So the theory of evolution would predict that a structure as unique as the body of a crab would evolve one time, just by chance, and that all crab-like creatures would be related to that one ancestor that evolved the crab-like body. And the fact that reality defies this prediction of evolutionists is a very strong piece of evidence against that theory. And the theory should probably be re-examined, if not completely chucked. But they don't have a good replacement theory, so they're just deciding, I guess nature likes a good crab. Okay, mutants. Now we're getting back to what your book says. Can you believe your book doesn't talk about crabs at all? I thought authors of textbooks liked crab-like features. Anyway, what'd you say?
I like crabs.
You like crabs? Yeah, they're delicious. Okay, so red box at the bottom of page 63. Mutants. In comic books, mutations result in superheroes with special abilities and powers. In the real world, the results of mutations are much different. Yet evolutionists insist that mutations have brought about the kinds of changes that have moved life from single-celled organisms to human life. Three main problems exist with this idea. Number one, mutations never form new types of life. Bacteria only forms bacteria. Plants always form new plants. Okay, so there are mutations. That is when there's an error in copying your DNA. Because when you reproduce, actually just like all the time as you're living, your DNA that tells your body what to do is constantly getting copied. Whenever you make a new skin cell, which happens all the time, that's one cell is dividing into two. And each of those two has a copy of the DNA from the one. It's really incredible with so many moving parts that we don't all just get cancer all the time. There's cancer again. Because cancer is very often the result of a mistake in DNA replication. You get a cell that doesn't have an off switch coded into its DNA because of some mistake, and so it just keeps making more and more and more of itself. And that's what cancer is. That's cancer the disease, not cancer the crab. I don't know why I'm talking about cancer so much. All of Pastor Larson's lecture had a natural tendency to evolve crab-like features. That's why this is a pastoral carcinization. Where on earth was I going? Okay. Mutations. No, I was trying to go away from crabs. Stop it.
I love crabs.
Crabs are awesome.
Mutations never form new types of life. Okay, so I wanted to talk about antibiotic resistance. Has anybody heard of that before?
What?
Okay, so 100 or so years ago, oh boy, I didn't look up the name. Somebody really awesome and famous developed penicillin. I'm so sorry, I can't remember the name of the scientist. Yeah, great guy.
Shoot.
And penicillin was discovered by accident. He was trying to grow bacteria cultures, and he accidentally got some mold in it, and he noticed the mold was killing the bacteria and ruining his experiment, and he was like, wait a minute, and antibiotics were born. So we've been using penicillin-based antibiotics for most of the last 100 years, and only recently have we started developing different kinds of antibiotics. And the reason we have started developing different kinds of antibiotics is because the bacteria are getting better at resisting penicillin. Yeah?
Alexander Fleming.
Thank you, Alexander Fleming. Yes, he is the inventor of penicillin and a fine specimen of scientist at that. It takes a good scientist to see his experiment ruined and then come up with a better experiment out of the ruined result. So anyway, Alexander Fleming invents penicillin, or discovers penicillin, and now we use it as antibiotic medicine. The problem is bacteria are developing a resistance to antibiotics. And to hear anybody in the media explain it, they would say the bacteria are evolving a resistance. So the idea is, let's see here, I'm going to stick with red and blue for this. So you've got your bacteria cells, and we're going to assume they're just one cell bacteria, and they're bad, and they're growing inside of your body. This is like in your eye or something, I don't know. And then you in your belly. Let's do that, because that way you can drink a medicine, and it comes down and it kills all of the bacteria. Bam, dead. And so now you're not sick anymore. But sometimes a single bacteria cell will survive, not because the medicine missed it, but because it has a mutation. I'm going to draw it a different color because it's a mutant. It has a mutation that makes it resistant to antibiotics. So antibiotics kill all the red bacteria, but the green one with the mutation that resists penicillin, the green one remains. So most of the time, your body's immune system, now that it's no longer overwhelmed by bacteria, is able to just kill the green one and have it done with. But in places like hospitals, where there are lots of bacteria from lots of sick people going around, there's a much higher chance that the green one will survive the antibiotic medicine and make its way into a different host body. And there it will replicate, right? Because that's how one-celled creatures reproduce. They just replicate themselves. And so now suddenly you have a new strain of bacteria, and you show the same symptoms because it's basically the same thing. But then when you take the medicine to kill it all, nothing happens because this is an antibiotic-resistant strain of bacteria. And so people will say, aha, the bacteria evolved to resist antibiotics. And it could be that there was an actual mutation that made it resistant to antibiotics. To get down to the nitty-gritty, you would have to look at what the antibiotic does that kills the bacteria. Another example is viruses. You know how you have to have how about COVID? they've always got new strains of COVID that need a new kind of COVID vaccine, right, in order for it to be effective. Or the flu vaccine is the same thing. I should have started with COVID rather than doing anything. I don't know as much about bacteria as I know about viruses. But the point that I'm making is, no matter how often these things mutate, they are still bacteria. They are not mutating to become some kind of, multicellular creature that has interconnecting systems or something like that would make it a more complex life form. It is still just a bacteria. And bacteria are, the reason I did choose bacteria is because bacteria reproduce very, very quickly. A human, if you really push the limits, humans can bear a new generation about every 15 years, right? Don't get into the ethics of 15-year-olds having babies, but a human can, humans go about 15 years from generation to generation. Bacteria reproduce like in minutes. So you could have literally millions of generations of bacteria growing in a petri dish. In fact, that's what our good boy Fleming was doing. He was growing bacteria in a petri dish, trying to observe how it responds to changes in the environment and what have you. And yet, even with, I think it's millions, but it might only be hundreds of thousands or something. Even with a crap ton of generations of bacteria in laboratories and hospitals and whatever all around the world, they have never been observed to evolve into something else. It's always just bacteria. It's a new strain of the same kind of bacteria. I'll tell you about the COVID vaccine real quick. So the surface of the COVID virus, if you look really close here, it has a special protein, and it's called a spike protein. And I'm just going to, I'm going to draw like a spike because it's a spike protein, right? And the way the first COVID vaccines worked, important thing. The spike protein is essential for COVID to operate. I think if the COVID goes up to a cell in your body, I should have drawn the COVID red because it's bad. The spike allows it to pierce the cell of the body, and I'm kind of speculating at this point, but stick with me here. Let's pretend in our magical strain of COVID that the spike is what it needs to pierce into the cell to release the DNA that forces the cell to make more viruses, and that's how viruses spread. What the COVID vaccine does, get out of here bacteria, you're not relevant. What the COVID vaccine does is it makes a whole bunch of spike proteins, but there's no virus attached to them. It's just a bunch of spikes. And then your body, your immune system, I'm going to use the eye thing again, your immune system is like, holy crap, there's a lot of foreign stuff here. We need to develop anti-spike proteins. And so it does. It develops these antibodies that are able to go and eat the spike proteins and render them useless. And then your body's like, hooray, I learned how to destroy spike proteins. That's how the vaccine works. The spike proteins are harmless, but when the real thing enters your body, your body, knowing what spike proteins look like, it says, uh-oh, let's unleash the anti-spike protein thing. And that's what it does. And so then the virus is rendered neutralized because it can no longer penetrate the cells. So that's how the COVID vaccine started. So then what happens? Well, some of the COVID viruses will have, let's call it a different shaped spike, right? Maybe it looks something like this, okay? Different shaped spike, and this is just a natural variation, just like how some people are tall and some people are short. Some COVID viruses have a pointy spike, and some COVID viruses have a spike that looks like a candle or something. And so the vaccine that taught your body to fight these kinds of spikes, it doesn't really work against that kind of spike. I don't know why, because it's fill in the blank. I don't know. I don't know why, but the antibodies that are designed for this kind of virus don't work against this. It's a different shaped structure, but it's still the same virus. And so the scientists in the health industry, they have to develop a new vaccine to teach your body to kill this different kind of spike protein. All of that to say is that nothing new has actually evolved here. There is either a mutation that just kind of very slightly changed the shape, or what's more likely is that there's just a natural variation within the COVID genome, and the natural variation just made a different shaped spike, just like some people have brown hair and some people have blonde hair, but they're both still people. And that's that level of change. And mutations cannot add up to something bigger than that, because what ends up happening is mutations always sacrifice something good and tend only to work in specific environments. So in my spike protein example, this shape is better at piercing cells than this one. And the only reason this shape even came about, the only reason this shape became prevalent is because suddenly this one didn't work anymore. So now this is an inferior shape, but in this particular environment, it's better suited to its job. And that's what a lot of scientists are finding with these superbacteria that are antibiotic resistant, is that, yeah, they thrive in hospitals where antibiotics are everywhere, but once you get out in the real world, they can't compete with regular bacteria, because the whatever mutation they have that resists antibiotics is not actually good. It only works in hospitals because all of the regular bacteria are getting destroyed by antibiotics. But out in the real world, those mutant bacteria don't really stand a chance. So all of that to say that antibiotic resistance and vaccine resistance and stuff like that is fascinating, but it is not evidence of evolution the way Darwin envisioned it. It's just a mutation changing a very small aspect of a species and it happens to help it thrive in a very specific environment. 2, I kind of already covered this one. Mutations are almost always harmful due to the loss of genetic material. Almost all mutations are sterile, unable to reproduce. Actually, almost all mutations die before they're even born. It's rare enough that a mutated life form actually survives long enough to come out of its mother or egg or whatever. And then when it does, it's more often than not sterile, meaning it can't reproduce. An example you might know of a sterile mutation is if you breed a horse and a donkey together, you get a mule. But a mule is not able to reproduce. The only way to get more mules is to breed more horses and donkeys. That indicates that horses and donkeys had a common ancestor, but the mutations and years of evolution by natural selection have destroyed their ability to reproduce properly. So again, nothing new was created, rather something rich was destroyed. And then 3, we've already hammered this one home. There are no transitional mutations alive today, nor any transitional fossils as evidence of past mutant organisms. So the missing link continues to be missing. Oh, I got ahead of myself. I forgot page 64 actually talks about antibiotic resistance. I'll just read what it says and add commentary, and then we'll be done soon. But wait a minute, I hear you saying. What about when bacteria become resistant to antibiotics? Or what about those insects that don't die even after you spray them with bug spray? Doesn't that prove evolution? Well, I would say, I don't know why the textbook author is suddenly speaking in first person, but whatever. That depends on what kind of evolution you are talking about. I'm not the biggest fan of the macroevolution, microevolution distinction because it makes it sound like one is just bigger than the other. Macro means large, micro means small. So it makes it sound like it's just a matter of quantity. But it's actually a matter of quality if you read it. Macroevolution, which is never observed, is the idea that organisms change from one kind to another. For example, a fish crawls out of the water and turns into a reptile, or a chimp decides to stand up one day and become a gorilla who stands even taller to become a human. Macroevolution is theoretical and unobserved. I don't like that your book, I don't like anything your book says on this page, to be honest. Nobody believes that a fish came out of the water and suddenly decided to live on land. That's not how any of this works. What they believe, and to their credit this is a little bit more believable, is that a fish is stranded maybe in a puddle that evaporates, and the fish just happens to have a structure that is able to metabolize oxygen from the air rather than from the water. And so it is able to survive on land long enough to reproduce, and or maybe even long enough just to get back to the water and then reproduce with other fish, but now it has inserted this new mutation into the gene pool, and that makes the fish more likely to survive in a drier environment, and it's very gradual. So yeah, even though it's never been observed, and I don't want to give the evolutionists any points, I also don't think it's honest to act like they actually believe what the macroevolution paragraph says, because nobody believes that, not even the evolutionists. Microevolution is that organisms change within their own type. Bacteria become resistant to antibiotics, but they remain bacteria. An insect may change in its reaction to bug killer, but it's still an insect. Microevolution is both observable and scientific. I want to close with this. This is actually getting back to the Bible. The Bible does have a word that kind of means species, but not really. The word is used all over Genesis chapter 1, and that word is kind. Not like being nice to your neighbor or something, but a type. I'll write type in parentheses just so we're all on the same page. And the phrase that the Bible uses is after its kind. So it talks about trees bearing seeds after its kind, or animals reproducing after its kind. And this idea of a kind of creature is the closest the Bible comes to defining what a species might be. And so according to God's creative plan, now we can classify animals however we want, because That's our, we can do that, we're scientists, whatever. But the way the Bible distinguishes creatures is whether or not they can reproduce. That's why I said with such confidence that horses and donkeys have a common ancestor on the tree of life. That God made a thing, and here it is. It's got 4 legs and it's kind of fat and it's got a head. God made a thing, and somewhere down the line, that thing actually did diverge, and we've got horses over here and donkeys over here. I don't know what do donkeys do. Yeah, same. I know they're very similar, so my stupid shapes don't mean much, but yeah, and these can no longer reproduce. Bad, but they do have a common ancestor. Excuse me, they can reproduce. They can reproduce, and they make a mule, which is something else stupid. So we're just gonna draw a line through that there. So the mule can't reproduce, but because the donkey and the mule, or the horse and the donkey can reproduce, we know as creationists that they have a common ancestor. So we do recognize, the lower branches of the evolutionary tree of life. We just take issue with the higher ones that try to connect all living things to a single cell organism that came to life billions of years ago. Okay, any questions?
The thing that really stuck was the crab.
The crab's good, yes.
Crab stuck.
Yes,
I
all
love
of our
Answer.
It sounds gross,
Yeah.
but they're good.
evolution likes crabs, or maybe God likes crabs. I think if we're going to personify the origin forces of the universe, I would rather it be God than chance. Okay, next time we are actually going to talk about the Bible more. So we're going to take a little break from the science, and we're going to talk about the Bible. We're going to get in lesson 16, why does the account of Adam and Eve matter? But then number 17 is evidence for the flood, and that's all kinds of science. And then the science unit will be pretty much done after lesson 17.
What?
They shoehorned in lesson 18, which is more Bible stuff. Is the God of the Old Testament the same as the New? And then we'll be done with science, and we'll get into more philosophy, which is maybe easier for some of you to stomach.
What's philosophy?
Philosophy is the general love of wisdom. It's actually, philosophy literally means love of wisdom.
Oh.
11.
Yep. So yeah, it's science is a branch of philosophy. Traditionally, it's called natural philosophy. But
So
there's
we
lots of other
don't have homework this week.
Yes. So homework again. I'm going to finish producing the assignment and upload it to the website. So if you want to get an early start, because it is a double-length assignment, it's a longer article and it's going to be 2 pages of questions instead of 1. So you would be wise to start the assignment before next Wednesday. But I was a confirmation student once, so I know how it goes. I will hand out hard copies next Wednesday, and it will be due the following Wednesday. Or if we get snowed out or something, I guess you'll have it over Christmas break.
I love being a lab rat.
You love what? Oh, being a lab rat. Yeah. Future classes won't have to put up with this shenanigans. They'll just get a hard copy right away.
What?
Let's head out and close in prayer. Well, it's still a double length assignment. It's just you guys are actually kind of missing out. Good night, everybody.